Good morning, students. So today we are going to discuss second part of our second chapter, solutions. Okay. Now, first of all, what is a solution? A solution is a homogeneous mixture of two or more substances. For example, lemonade, soda water, etc. They are all examples of solutions. In a solution, there is homogeneity at the particle level. Okay, there is homogeneity at the particle level. What does it mean? It means that lemonade tastes same throughout. Okay, it means when we take the first sip of lemonade, whatever taste will be there, same taste will be observed till the last sip. It means that whatever components were there which were dissolved for making that particular solution, those are distributed evenly. There is even distribution of all the components. Okay. Now, when we talk about solution, then we may think that it is a liquid. It is a liquid in which either solid or liquid or a gas is dissolved. Okay, but there are two more types of solutions. One is solid solution and another is gaseous solution. Solid solutions are given another name, alloys. In gaseous solutions, for example, air means gaseous solution. So in gaseous solution, all the components will be gas, and in solid solutions, all the components will be solids. Now let us talk about alloys. What are alloys? Alloys are mixture of two or more metals. One thing is, when we mix two or more metals, then there is formation of alloy. Second is, when we mix a metal and a non-metal, okay, then also one alloy can be formed. Now, if we have prepared an alloy, then we cannot separate its components by simple physical methods. Okay. Now, we are saying that alloy, we will keep it in the category of mixture. Why we will keep it in the category of mixture? Because you have done compound and mixture. Now, why it is mixture? Because in the definition of mixture, we can have constituents in any ratio. Their composition can be in any percentage. So we are keeping alloys in the category of mixture. Okay. Now let us take one example. Brass is an alloy. Okay, now it has been prepared by mixing 30% zinc and 70% copper. Okay, now in the examples of brass, you can see where it can be used. So it is useful for making a large number of articles. Okay, now let us discuss components of solution. Now there are two components of a solution. One is solvent and another is solute. So what is solvent? That particular component which is present in more amount, okay, and in which we can dissolve any other component. So that particular component will be termed as solvent. Similarly, the component which is present in less amount and can be dissolved in any other component is called solute. Now let us take one example. If I am taking 1 spoon of salt and a glass full of water, then if I dissolve these two, means if I take this salt and dissolve it in water, then salt solution will be prepared. So water is in more amount, so water behaves as solvent. And similarly, salt is in less amount, so we will say salt is solute. Okay. Now let us understand with the help of few examples. Very first example, water, when we take in a glass and we put 1 or 2 spoons of sugar, then sugar becomes solute, water becomes solvent, and whatever is obtained after mixing it, it is a homogeneous mixture, so it is solution. Similarly, tincture of iodine. Tincture of iodine contains iodine, which is solid, and alcohol, which is liquid. Just like here water is there, in this case alcohol is there. Here sugar is there, in this case iodine is there. And then we get tincture of iodine, one solution called tincture of iodine. It is having a medicinal value. Okay, so this becomes a solution. Third, you have seen cold drinks. As many cold drinks are there, they all are termed as aerated drinks. Now, aerated word is given to these because they all contain dissolved gas in them. Now, if we talk about these aerated drinks, just like here you can see bubbles. Okay, so what are these bubbles? These bubbles are of carbon dioxide gas which is dissolved in liquid or which is dissolved in water. Okay, so when we dissolve it, it is done at a high pressure. So when pressure value is low, then what happens? Then the gas starts coming out of the liquid and we are able to see the bubbles. So in aerated drinks we will say that carbon dioxide gas is a solute and water is a solvent. Similarly, air is gaseous solution. So you can see this clear sky. Clear sky means there is presence of mixture of gases in which nitrogen is in more amount 78%, oxygen is in less amount 21%. There is presence of other gases also, but if we talk about only these two, then we can say nitrogen gas behaves as a solvent and oxygen gas behaves as a solute. Okay, now let us discuss about the properties of solution. Very first property, solution is a homogeneous mixture. Second property, the particle size is less than 1 nanometer. 1 nanometer is equal to 10 raised to power minus 9 meter. Okay, so nano stands for 10 raised to power minus 9. Okay, now see, this is so small size that we cannot see it with the naked eyes. Okay, it is impossible to view it with the naked eye. Just like when we dissolve 1 spoon of salt in water, then what happens? Salt dissolves and we cannot see the particles of salt. Okay, now one more effect is there, that is called Tyndall effect. It is the name of scientist after his name. This effect is termed as Tyndall effect. Now what is this effect? This effect means that scattering of beam of light when it is passed through a particular solution. That solution is not a true solution or the solution about which we are talking. If it is colloidal sol or if it is suspension, then those particular substances can scatter a beam of light when light is passed through them. Now, why it happens? Because in their case, in those two cases, particle size is larger and those particles are capable of scattering the beam of light. But when we take solution, then particle size is very small. So because of very small size, they cannot scatter the beam of light. Okay. Now this word, when we are saying scattering means, what does it mean? It means that path of light is visible or not visible. If we say path of light is invisible, then we will say that there is no scattering of light. If we are able to see the path, then we will say that there is scattering of light. Okay. Now one more property, solute particles cannot be separated from the mixture by the process of filtration. Filtration we have done earlier. So whenever we have prepared a solution, if we perform the process of filtration, then we will get the same solution as filtrate. There will be no residue. So it means we cannot separate the solute particle from the solution by filtration. Okay. One more property. Solutions are stable. Solutions are stable means whenever we have prepared a solution, that solution will remain as it is. Just like if I have dissolved 1 spoon of sugar in 1 glass full of water, then it will not happen that if I place the glass for some time, then sugar will settle down. This is not going to happen. Okay. So if solution as we prepared, it remains as it is, then we will say that this solution is stable. So what is the point? Point is that solution is very stable. Its particles cannot settle down. Okay. Now one more thing, concentration of a solution. Now look at the picture. If you see this one and this one, then what is the difference? One is very dark and one is very light. So this color is because of the presence of solute particles. If solute particles amount is very less, then it means that solution is less concentrated. And if there is darkness, then we can say that that there is presence of more solute particles and this solution is more concentrated. So dilute and concentrated, these terms are comparative terms. Okay. We can comparatively say that a particular substance is less concentrated in comparison to other or no. Now see, let us take this example. If I take this substance, this particular solution, then I will say this is more concentrated than this. Okay. And this is less concentrated than this. Okay. So at the same time, this is more concentrated also and less concentrated also. It depends on with which I am comparing this. So this solution is more concentrated than this. Okay. Similarly, this is less concentrated than this. So what we can say, that dilute and concentrated are comparative terms. Okay. Now this thing is called concentration. Now what thing is deciding the concentration? Amount of solute is deciding the concentration of the solution. So what is concentration? Concentration of a solution is the amount of solute present in it. Okay. So whatever we have studied till now in this session, you have to solve these home assignments on the basis of that. Okay. Thank you.